So this is question 51 on page 28 of your notes packet. What is the maximum amount of ammonia? So ammonia is the product that I want to be looking into. That's NH3. The maximum amount of ammonia in grams that can be synthesized from 45.8 grams of nitrogen monoxide and 12.4 grams of hydrogen gas. So how we approach these problems is we do two stoichiometry problems. I start with each of those reactants, and then I figure out how many grams of NH3 I can make. So this one has the parentheses sort of already written for you, right? This would be when I would start with the 45.8 grams of nitrogen monoxide. I would do a 3 parentheses stoichiometry problem, first converting to moles of nitrogen monoxide, then moles of NH3, then grams of NH3. Put this into my calculator. I get 26.0057 grams of NH3 that can be made. And then I would start with 12.4 grams of hydrogen. Again, 3 parentheses, stoichiometry problem. Both of these, notice what I'm converting to. I'm converting to the mass of the NH3, the mass of ammonia. Here I have 41.8407 grams of NH3. So this tells me when I use up all my nitrogen monoxide with an unlimited amount of hydrogen, I could make 26 grams of ammonia. If I use 12.4 grams of hydrogen with unlimited nitrogen monoxide, I could make 41.8 grams of ammonia. So since this is the lowest number, the smallest number, that's the maximum amount of product that I can make. I'm just going back for significant figure purposes. All of these numbers have 3 significant figures here. So I'm just going to round this to 26.0 grams of NH3. So what is this? This is my theoretical yield, and which reactant was my limiting reactant? The nitrogen monoxide. Okay, so since the 45.8 grams of nitrogen monoxide will produce the least amount of product, it must have run out first, and thus was the limiting reactant, right? Only 26.0 grams of ammonia can be made before the reaction stops and the nitrogen monoxide runs out. Right? I really want to make sure that we understand that once the nitrogen monoxide runs out, then the reaction stops. And that means that there's going to be some of the other reactant left over. And that's what the second part of this question is asking us. What mass of the excess reactant is left over? Remember that this reaction was nitrogen monoxide and hydrogen gas as the 2 reactants. Just go back, right? There's the balanced chemical equation here. Here's the nitrogen monoxide and the hydrogen gas as our 2 reactants. We, through our calculations, found that the nitrogen monoxide, the 45.8 grams of nitrogen monoxide, is going to run out first, which means there's still going to be some hydrogen left over, some hydrogen that did not get used. That's what this question is asking. What is the mass of the excess reactant left over? What is the excess reactant? The hydrogen. So how am I going to do this? Well, think about just what that word left over means. If I ask you, if any situation you're asked how much is left over, what you do is you think of, well, how much did we start with? And then how much did we use? And the difference between those 2 numbers is what was left over. I try to use this an acronym, SUE, like the name SUE, start minus used equals excess, right? That word excess and left over, they refer to the same thing. So how much hydrogen did I start with? Okay, we'll go back to the beginning of the question. It said I started with 12.4 grams of hydrogen. Now, how much did I use? This is not a number that you have figured out yet. Okay, so this I'm going to need to do a calculation for. Then I'm going to subtract those two numbers, and that will give me the amount of excess reactant. So I go back and start with the limiting reactant, because remember, the limiting reactant is what is controlling this reaction. This is what, when it runs out, the reaction stops. What I want to find is, if I use up all my nitrogen monoxide, how much hydrogen will I also use? These two must be the same unit, grams, but also must be the same chemical. So I'm going to do another 3 parentheses stoichiometry problem, converting from the grams of nitrogen monoxide, but now not to a product, to the other reactant, because the question that I'm answering here is how much hydrogen will I also use when I use up all of the nitrogen monoxide. Okay, put this into my calculator and I get 7.707 grams of hydrogen is what gets used. So I start with 12.4, I use 7.707, and I do that subtraction, and I get 4.692 grams of hydrogen left over. Before I call this done, right, I need to worry about obviously units and significant figures. The only way that I can subtract is if the things that I'm subtracting have the same unit, right? 3 apples plus 5 apples is 8 apples, but 3 apples plus 5 oranges, I can't do that. So we need to make sure that this was grams of hydrogen and this was grams of hydrogen, so that is grams of hydrogen. Now I need to worry about significant figures and decimal places, because the last step here is a subtraction. I'm not going to worry about significant figures. I'm going to worry about decimal places. This question, 12.4, has, or this number, 12.4, has 1 decimal place, 1 digit past the decimal point. If I'm doing this, this number would have 3 significant figures. So this number, when I round it correctly, would actually have 2 digits past the decimal point. So since we go with the smallest one, I'm going to round this to 1 digit past the decimal point. So my answer here is actually 4.7 grams of hydrogen gas left over. Okay, so let's review this question from start to end. I was given an amount, a gram of 2 reactants, and the first question was how much ammonia can be made. So I figured out if I started with 1 reactant, how much ammonia could be made, the second reactant, how much ammonia could be made, and the lowest amount of ammonia is my answer, is my theoretical yield. So only 45.8 grams, only 26 grams of ammonia can be made because my 45.8 grams of nitrogen monoxide will run out. And then I answered the question about the excess reactant that was left over. I figured that that was hydrogen, and then I did this additional calculation. I started with my limiting reactant, and I did a 3 parentheses stoichiometry problem to find the other reactant. In this case, the hydrogen. And then I subtracted those. So anytime I'm asked for excess, start minus used equals excess, right? So. Okay, we have one more practice problem to do today. So again, if you feel like you are, you want to test yourself, stop the video or do the next problem and then watch the next video to see how to do it.